Yeah, Mr. Sigaro, I'll be taking you through remote sensing. What is a remote sensing according to your understanding? Remote sensing is the acquisition of information about an object or phenomenon without making physical contact. Contact with the object and co- the term is especially applied to acquiring information about the earth. Remote sensing is the process of detecting and monitoring physical characteristics of an area by measuring its reflected and emitted radiation at a distance without, which can be from satellite or an aircraft. Remote sensing is the science and can also be defined as an art of acquiring information about the Earth's surface without actually being in contact with it. This is done by sensing and recording reflected or emitted energy and processing, analyzing, and applying that information. Especially cameras collected remotely sense images, which help researchers sense things about the Earth. Example of cameras used on remote sensing. Cameras on satellites and airplanes take images of large areas on the Earth's surface, allowing us to see much more than we can see when standing on the ground. Sonar system on ships can be used to create images of the ocean floor without needing to travel to the bottom of the ocean. Cameras on satellites can be used to make images of temperature changes in the oceans. Some of the use of remote sensing data. Large forestries can use remote sensing to observe forest fires, can be mapped from space, allowing rangers to see a much larger area than one from the ground. Tracking clouds to help predicting weather or watching erupting volcanoes and help watching for us for dust storms. Tracking the growth of city and changes in farmland or forest over several years or decades. Discovering and mapping of the rugged topography of the ocean floor. Types of platform. There are two types of platforms used in remote sensing. First platform is a ground-based platform. Ground-based platforms are used to record detailed information about the object or features of the Earth's surface. These are developed for the scientific understanding on the signal objects and signal sensors. Interaction on ground observation includes both the laboratory and the field study used for both signing sensors and identification and characterization of land features. Current observation platform include handheld platform, cherry pickers, towers, portable masts, and vehicles. Portable handheld photographic cameras and spectrophotometer are largely used in laboratory and field experiment as reference. Airborne or air-based platforms. This is the second platform used in remote sensing. Airport platform was the sole non-ground based platform for early remote sensing work. Aircraft remote sensing system may also be referred as suborbital or airborne or aerial remote sensing. System at present airplanes are the most common airborne platforms. Other airborne observation platforms include balloons, drones, and high altitude sounding rockets. Helicopters or occasionally used balloons. Balloons are used for remote sensing observation, aerial photography, and nature observation. Spaceborne platform. This is the third platform used in remote sensing. In spaceborne platform, remote sensing sensors are mounted on a board spacecraft or satellite, orbiting the Earth space or satellite platform are one time. Cost affected but relatively low cost per unit area of coverage can acquire imagery of the Earth without making permission. Space for an imaging ranges from altitude of 50,000 kilometers to 50 kilometers to 36,000 kilometers. And manned satellite platform, Landsat series or Spot series and IRS series of remote sensing satellite. Series of meteorological satellites, the entire constellation of the GPS satellite and goes inside series of geostationary environmental communication, television broadcast, weather, and app. Observation satellites are examples of unmanned satellite category. Therefore, the next part is the types of resolution. The first type of resolution is the radiometric resolution. It is the amount of information in each pixel, the number of bits representing the energy recorded. Thus, the radiometric resolution, the more values are available to store information, providing and better discrimination between FM the slightest difference in energy. For example, when assessing water quality, radiometric resolution is necessary to distinguish between subtle and subtle difference in ocean color. The second type of resolution is a spatial resolution. Is defined by the size of each pixel within a digital image and the area on the Earth surface presented by that pixel. The finer the resolution, the lower the number, the more detail you can acquire. The second part is the types of sensors. Here we have two types of remote sensing sensors. Remote sensing platform sensors. First one is a passive remote sensing. Passive sensors. The sun provides an energy convenient source of energy for remote sensing. The sun's energy either reflected as it's for visible wavelengths or absorbed and then emitted as it is for thermal infrared wavelengths. Remote sensing system which measure energy that is naturally available are called passive sensors. Passive sensors can only be used to detect energy when the natural occurring energy is available. For all reflected energy, this can only take place during the time when the sun is illuminating the earth. There is no reflected energy available from the sun at night. Energy that is naturally emitted, such as thermal infrared, can be detected by day or night, as long as the amount of energy is enough to be recorded. The second part is the active sensors. On the other hand, active sensors provide the energy source for illumination. The sensors emit radiation which is directed towards the target to be investigated. The radiation reflected from the target is detected and measured by the sensor. Advantages of remote active sensors include the following. One, the ability to obtain measurement anytime, regardless of the time of the day or season. Active sensors can be used for examining wavelengths that are not sufficiently provided by the sun's energy, such as microwaves, or to better control the way a target is illuminated or wave. However, active sensors require the generation of a fairly large amount of energy to adequately illuminate targets. Some examples of active sensors are laser fluorescence and synthetic aperture radar. The next part is radiation in the atmosphere. Yeah, we are going to look at the radiation taking place in the atmosphere, which can be used for remote sensing. The atmosphere influences incoming radiation by atmospheric scattering and atmospheric absorption. These processes are covered by the following. One, size of the atmospheric particles that is prevailing atmospheric conditions. The second is the nature of the incoming radiation, mainly its wavelength. That one is the scattering. Scattering is a process of diffusion caused by the redirecting of the radiation by particles of different sizes that are present in the atmosphere. And we are going to look at the relay scattering. Relay scattering occurs when the wavelength of the radiation is larger than the diameter of the particles interacting with the magnitude of scatter. As the wavelength decreases, the blue color of the sky is the result of relay scattering, since the shorter blue wavelength in the visible part of the spectrum are diffused all over the sky. The next part we are going to look at the application of remote sensing. Remote sensing is used in many states by natural resource management of the forest sector. Both private and state forestry agencies use remote sensing majorly for assessment, supporting analysis, and management of the forest. Remote sensing data is essential when element of forest inventories. The forest sector is second to the military in using remote sensing data for inventory purposes. Remote sensing is the use of all spaceborne and airborne instruments for observation of the Earth. Some of these instruments include optic electric system and the synthetic aperture radar. Positioning of the navigation system along with terrestrial remote sensing system are essential. For example, based field measuring and sampling. The next application of remote sensing is the transport and infrastructure. Remote sensing technologies together with GIS and position navigation and the navigation system can play a significant role in improving the nation's transformation security and protecting critical infrastructure. Remote sensing from space combines a broad synoptic view with the ability to detect changes in surface features quickly and routinely. Remote sensing from an aircraft allows analysis to examine areas in great detail from the below. The clouds and the ground-based system make possible the close in observation of events. In real time, each of these spheres of remote sensing technology hold benefits for use in transportation, and in particular for security of the nation's complex transportation network. Example of the use of remotely sensed data to support transportation security include the ability to develop accurate digital terrain models and 3D surveys features and means for modeling. Last, we are going to end there. We'll proceed from the next time.